Okay, so arc10 of x looks like this. Right, so approaching pi over 2. When it's 1, it's going to be 1. So 1, it's 1. When it's 2, it's going to be, okay, let's say that's the value. But it's essentially we're looking for an angle, tangent of theta. When does it equal to 2? It's not going to be a special angle. So it's actually 1.11. Just a little bit higher than this. Okay, so what's the difference between this arc10 graph and arc10 root of x? Okay, so whenever you have an x, you affect the x before the main function of arc10, it has an opposite effect, right? So for here, if I plugged in 1, I got 1. Actually, that's not a good example. Let's do this. Here, I had to plug in 2 to get 1.1. For this one, because it's square rooted, I have to square, so I have to put 4, and I'll get the same 1.1. So it's essentially a stretched graph. Okay, it's going to look like this. You can see the area has to be smaller than arc10. Okay, this one is even more tricky. We have sine, okay, sine of x as an input into arc10. So let's draw the sine of x. Okay, so it looks like this. And we're only concerned about 1 to 2. So pi is roughly 3. So from 1 to 2, let's say. Okay, 1 to 2. If we put 1, we're going to get a value that's less than 1. So when you plug in 1, right, we're going to get sine of 1. So again, the graph's going to be lowered. Right, so we plug in 1 and we get this value instead, which is less than 1. So we're going to get a height on the normal arc10 graph that's less than 1. So it's going to be here. When you plug in 2, you're going to get this x value instead as an input into the tangent, or something smaller. Again, if that's the y value, that's what it will be. Okay, so it will look like that. Again, this graph is lower, right, below this one. Okay, so we can say since arc10 x is greater than, okay, I should say greater than equal to arc10 root of x or arc10 sine of x, we can say the area from 1 to 2, arc10 x, is the largest.